So welcome to everyone. In this video, we are going to learn parabola by general method. In this video, we are going to learn parabola by general method. The question is construct a parabola when the distance of the focus from the directrix is 50 mm. So here they have given the distance between focus from the directrix is 50 mm. Okay. So in our question, if they didn't mention the curve name, we will be uh, look at this eccentricity value. Okay. So if the eccentricity value is greater than 1, the curve will be a hyperbola. If the eccentricity value is less than 1, the curve will be ellipse. If the eccentricity value is equal to 1, the curve will be a parabola. Okay. So for parabola, eccentricity value is 1. So in our question, focus and directrix, uh, between these two points, they given the distance that is 50 mm. Okay. First of all, we need to construct directrix. Okay. Directrix means it is a fixed line. Focus means it is a fixed point. The distance between directrix and focus is 50 mm. Okay. First of all, we need to draw directrix line. Then after we need to locate focus point. Okay. First of all, take the line command. Take the line command. Draw a line. Okay. This is the fixed line. This line name is directrix. Give the notations by using the single line text. Click where you want and enter the text height, that is 5. Enter and give the rotation of the text, that is 0. Enter. So give the naming directrix. Next, this point is A and this point is B, and middle this point C. Okay. Next, so take the line command again for locating focus point. Take the line command from this middle of the directrix, from the middle point of this directrix, draw a line which is equal to the distance between the focus and directrix, that is given in the question 50 mm. Okay. So here we need to mention the focus point. I am copying C and paste it here. Double click on C and edit it as F. Okay. This is the focus point. Focus will be indicated by F. Okay. Next, mention the dimension from C to focus. Yes, it is exactly 50. Now, we need to divide this line into two equal parts. How to divide? By using divide command, we can divide this line into two equal parts because eccentricity value is 1. Okay. So, divide div. The shortcut is div. Enter and click on this object, that is the line. Okay. Select the object to divide means this line and enter the number of segments. How many segments? Two segments. Enter. Okay, this is the point. This is the point. We need to mark. We need to mark as a vertex. Okay, this is the point vertex. We can denote it by V. Next. So after that, this line is we can call axis line. Okay, this line is axis line. This is axis line. Which is axis line. Next, after this vertex, we need to draw a perpendicular lines. We need to draw a perpendicular lines to this axis line. So for that, first of all, we need to draw a vertical line through this vertex. We need to draw a vertical line. This vertical line, I am going to offset. I'm going to do offset with certain distance. The distance may be our choice. We can offset this line with 10 mm or 20 mm or 30 mm. So now I am going to offset this line with 10 mm of distance. Okay. So offset, the command is O, shortcut O, enter, and specify offset distance. The specify offset distance means 10 mm. Okay, 10 mm distance between two lines. So click on this line and click on how many parts you want. You can keep on click on. Okay, I have offset this line into 5 lines. Okay, 5 parts. Next, give the naming of these points. Okay, point 1, point 2, point 3, point 4, and point 5. Further, click the single line text and click where you want. Enter height of the text and rotation of the text. So this is the point 1 and this is point 2 and point 3, point 4 and point 5. Escape. Okay. This is the focus point. Okay, this is the focus point. Now, so extend these lines with some distance. Now, we need to mark the points for drawing the parabola curve. Okay, we need to mark the points on this perpendicular lines for drawing the parabola curve. So for that, we need to take the radius from the directrix to point 1 and from the directrix to point 2 and from the directrix to point 2, and each and every point we need to take the radius and mark on these lines. Mark on points on this line. Okay. First of all, take the circle, C as the center, 1 as the radius, draw a circle, and this circle we need to move to focus line, focus point. Okay. C to 1 as the radius, C as the center, C to 1 as the radius, draw the circle, and this circle we need to move to the focus point. Okay. This circle and this perpendicular line will meet at this intersection point. This point is point P1. Okay. This is the first point of this parabola. Give the naming. So I'm copying this one, Control C and Control V, and double click on it and edit. This is the point 1 dash. Okay. P1 dash. So, and also by using point command, place the point. Okay. And next, C2 2 as the radius, C as the center, take another circle. Okay. C2 2 as the radius. I'm increasing the radius from 1 to 2. I'm increasing the radius from 1 to 2. I'm using the same circle and move the circle to the focus. Move the circle to the focus and mark the point. Mark the point on second line. Okay. This is the point on second line. Okay. This is the point V2. So I have done a mistake for the first point. C21 as the radius, F as the center, mark the point on the first line only. So be careful while marking the points. No need to mark on the vertex point. Okay, vertex perpendicular line. You don't need. We don't need to mark the point. Only we need to mark the points on perpendicular line, first perpendicular line, and second perpendicular line, and third perpendicular lines. Okay, so we don't want this vertex. Erase it. Okay, so we got 2 points. Give the naming also. This is P2 dash, and using this circle, C as the center and 3 as the radius, and move to this circle, F as the center, and mark the point, that is third point. So using point command, I am placing the point, and this is the point P3. Okay, and next, using the same circle, increase the radius 3 to 4 and move this circle to the focus point and make another point, locate another point, that is the point P4. Double click on it and edit 4. And also we have another perpendicular line, that is the fifth line. C as the center, C to 5 as the radius, and F as the center. Locate the point 5. Okay, point and Okay, this is the point 5. In similar manner, we need to look at the points below the axis line also. Below the axis line, we need to look at the points. For that, we have a command that is mirror. We are mirroring all these points below the axis line with the help of mirror command. So we don't want the circle, we can erase it. Okay. So select all these points. First of all, select all these points and go to mirror command. Here we have a mirror command. Click on it and specify the first point. Click on this C. Click on C point C and click on this axis line. Anywhere on the axis line, we can click on it and erase the source object. It asking you, the command line is asking you, erase the source object. Always say no. Okay, we got another 5 points below the axis line. So give the naming also for these points. Now this is the point P1 only without a dash. This is P2 without a dash. This is P3 and this is P4 and last one P5. Okay, so extend this line also and trim it. Sorry. Okay, now all points are we have located. So with the help of the spline command, we are going to join this all these points. Okay, so the spline command will be available on draw to ribbon area. This draw toolbar, we have a spline fit. Using this command, we are going to join all these points. Okay, click on this point 5 and the point 4, point 3, 2, 1 and click on this vertex point and the point 1, 2, 3, 4, 5 and enter. Press enter. Okay, this is the curve, that is parabola. Okay, this is the curve parabola. Okay, okay. In our question, they didn't ask that draw the tangent and normal. So in our examination, maybe ask draw tangent and normal also in some cases. So for that, how to draw tangent and normal? So I will explain now. So first of all, on this curve, on this curve, we need to select a point. We need to select any point on this curve, or we need to place a point any place anywhere on this curve. So for example, I am placing the point with the help of point command uh, over the here. Here I am placing the point. This is the point P. For example, this is the point P. Just a P. Okay. So from this point, from this point, we need to join this point to F, focus point. Okay, with the help of line command, I'm joining uh, this point to F, and copy this line, copy this line, paste it somewhere here, and rotate this line into 90 degrees. 90 degrees. Okay, and move to this line to this focus. Okay, from it is mixed to this directrix line. Here we have some gap between these two. This is the point. For example, we can call T. Okay, Control C, Control V. This is the point T. From this point T to we are already located a point that is P here. Okay, draw a line. Draw a line from T to this P, point P. Okay, this point P. So this is the tangent line. This line is we can call tangent. Copy this line and paste it somewhere and rotate 90 degrees, the 90 degrees to this line. So we get normal. Okay, copy this line and paste it somewhere. Rotate this line into 90 degrees. Okay, so I'm entering the rotate, select specify base point, click on anywhere, click on anywhere and enter 90. This line is rotated by 90 degrees. Okay, move this line to this point, to this point where we have, this is the point, this is the point. Okay, we don't want this line. Okay, this is the normal line, this is the tangent line. Okay, give the line weight for clear visibility, give the line weight for clear visibility, and this curve also give the line weight, and give the color if you want. Give the color these two lines also for differentiating these lines. Okay, this is normal line, and this is in called the tangent line. Tangent line. Okay, so with the help of this leader line, with the help of this leader line, I am giving the naming of this line and this line also. Okay, this is the procedure for drawing this parabola in general method. General method or eccentricity method, both are same. Okay, uh, thank you.